So I'd like to make a practice problem that looks like the problems that we did today in class, but I will not use a calculator right now so that you guys can see how a problem like this can be done by hand. So here's the problem that I'd like to try. So suppose this exercise is what you see. The first thing that I would do is label these points, x1, y1, x2, y2. Now the goal is to write the equation in standard form. So recall that the convenient order is point slope to slope intercept to standard. So first things first, let's find the slope. So my slope is y2 minus y1 over x2 minus x1. And this can become negative 12 over positive 8 because recall that here this becomes addition. And now I see that I have the opportunity to reduce this fraction by 4. And so now this here, that is our slope. So we have that ready. Now let's jump off into point slope. And recall that point slope has its name because point and slope are what you need. We have the slope right there. As for a point, we have two original points to choose from. It doesn't matter which one you pick. You can pick this one or you can pick that one. Suppose that to be different from what we did today, suppose I pick this. Then honestly, once you've made that selection, now this is like x1 and that's like y1. See what I'm saying? If you want to pick this one, they would become x1, y1 so that you could feed them into these spots here. If you don't want to do that, then just use this point instead. Either way, you'll get the same answer. So let's make these substitutions. So here's what I have, y minus, and then y1 was negative 4. And then the slope goes here, and then it's x minus x1, which is that point there. We can make this double negative positive, and we can also distribute that fraction. So let's see. So this is y plus 4 equals, that times that is just negative 3/2 x, like that. Now here, this is where I would use a calculator, but I said I wouldn't use a calculator, so let me do some scratch work here off to the side. I have negative 3 over 2, and it has to be multiplied by negative 3. So let's see, focusing up here now, underneath the negative 3 there is a 1. If you want to multiply two fractions, you multiply the numerators, and in the bottom, the denominators. So upstairs, it's negative 3 times negative 3, which is 9, and in the bottom it's 2 times 1, which is just 2. And it's positive, right? So over here, I have positive 9 over 2. And so now what I want to do is I want to subtract 4 from both sides. I know that here they eliminate. And I have y equals negative 3 over 2x. Now, here again is where I would use the calculator, but I'm not going to use one right now. So instead, I'm going to say that's positive 9 over 2. And then it's minus 4. Now, underneath the 4, there is a 1. But if you want to subtract fractions, you have to have a common denominator. And if this is 2 and if that's a 1, I can multiply this by 2 because the bottom would become 2, which matches with this. But if you multiply the bottom by 2, you also have to multiply the top by 2. So this becomes 9 over 2 minus 8 over 2. And that, of course, is just 1 over 2. So that 1 over 2 goes back here. And now I do wish to remind you that what we currently have there is slope-intercept form, right? But our goal is to form standard. We want standard form. And so for standard form, you have to make sure that the x's are on the other side. So this piece has to be moved to the left-hand side. Now, if this piece is negative on the right, it's going to be, of course, positive on the left. So I'm going to add it to the other side. So it would be positive 3 over 2x plus y equals, and the only thing left on this side is the 1/2. And then do recall, folks, that for standard form, your a, b, and c values have to be integers. Right now, we have fractions with denominators. So let's get rid of those denominators. We can multiply both sides by 2. But you have to make sure that you distribute, right? You got to make sure that you distribute. So let's see what we get. Here, 2 times 3 over 2 is just 3. And you keep the x. And then 2 times y is 2y. And then 1/2 times 2 is just 1. So the proposition is that this is the line in standard form that connects these 2 points. And to show you guys that this is true, I have a picture here from Desmos which clearly shows that the 2 original points are contained by that line. So anytime you guys do a problem like this, if you want to double check your answer, you can plot whatever points you have along with what you think is the answer, and Desmos should verify your math. So I hope you guys found this helpful. Have a great weekend, guys, and I'll see you all next week.